Fundamentally, the most important thing you can do to improve your own open source security or supply chain security posture is to start by just making sure that you know which components you're using, what are the problems in them, and how do you address them. And in conveying to the upstream maintainers that this is important to you, to convey to the world that you have chosen library X over library Y because you believe it to be more secure. Open source maintainers are amazing individuals that are producing free software that makes the world better or more productive, and they're really great. And fundamentally, they cater to their communities, especially the top ones. So the more their communities express a desire and importance for security over functionality, the more weight they get from their consumers to say, I am willing to forego this enhancement.
Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's SNYK.io/TSD.
Thank you for joining us for part 2 of the Software Supply Chain series. In part 1 of this series, we deep dive into what software supply chain security is, the components, and why it's become so important to pay attention to it. This week, we're going to be dissecting some key terms like SBOM and introduce some key players and promising projects in this space. So let's get into it. When we think about the prevalence of open source libraries in our applications, what is actually running in our production environment, a large proportion of it is open source. Third-party libraries written by people that we don't employ, the open source maintainers, and any kind of open source contributors. If you're really unlucky, even I might have contributed some code to your application. Are there effective mechanisms to truly understand and have visibility into all of these libraries and this entire estate? Do we have some kind of log or artifact that we can really state what we're using under the covers? One term that has become quite synonymous with supply chain security is SBOM. And we have Guy Podjarny and Lena Smart, CISO of MongoDB, to share a bit more about this topic with us.
So I think the object in question and kind of the keyword, if you know anything about software supply chain security, you must have heard is the SBOM, the software bill of materials, which actually is a term that dates, a fair bit back, but has only now kind of made its way to prominence. And the SBOM is a bit of a love-hate kind of type term for experts in the field. On one hand, it is a very important artifact to it. On the other hand, it is not the be-all and end-all. It's not that if you've produced a software bill of materials, then you've kind of solved the world. I think fundamentally, in software supply chain security, as it pertains to open source components, there are probably 2 primary streams on how do you secure it. One is SBOM related, and the other is more workflows. On the SBOM front, it starts from you need to know what you're using. So just start by sheer curation of knowing what you are using, forget formats and how that file is, but just understand which libraries are there, tracking it in your source code, tracking it in your build system, tracking it in your deployed systems to just know which components are out there. If you don't know that, you can't do anything about it. You can't manage it. You can't report it. On the internal side, once you know which components you're using, you need to know whether they are any good. Are there known problems in them today? Are there known vulnerabilities? Are there known license issues? And then set yourself up to act on those. How do you fix them? How do you triage them? How do you prioritize which ones to address? Because invariably, you're going to have many, many components. There will be many issues in it. So more often than not, you can't really address all the known problems in them, but you should build a system where you're trying to do your best at choosing the ones to address and, a variety of solutions out there to help simplify that. So the second aspect of it is how much do you trust a component and how much do you anticipate that it may or may not actually turn out to have a vulnerability or turn out to have been malicious and run by someone with a malicious intent. And so this notion of trustworthiness is a bit of a level up, it's a bit of a 202 maybe versus the start, but it is trying to anticipate if You can look for signals like, or the maintainers from a country that you might be uncomfortable with, especially if this is a government system. You can look at things like what are the security practices that may or may not be running as part of this component's ethos. Maybe you try to assess the learning of it. And there's a bunch of projects in OpenSSF that we'll talk about down the road, like a scorecard that touch on that. So those two are sort of on the internal side of SBOM. And on the external side of SBOM, this is really where it's the most new to the industry, and due to the executive order has been really kind of rapidly promoting, which is now that you know your software bill of materials, and hopefully you're doing your job managing it internally, now you are required, if you're shipping software to a customer, to provide them with your software bill of materials with the SBOM. There are a couple of new standard formats that kind of try to help streamline that type of exchange. So you provide them with that information. And similarly, on the consumer side, now you're going to get SBOMs from all these different vendors all these different providers. You need to decide what you do with them. And this reporting and managing of the SBOMs is the newest area in terms of like an industry practice. And so it's probably the most formative.
Also, to my mind, the perfect SBOM would be one that takes almost a real-time snapshot of the way that your shopping list of software is, which effectively is what the SBOM is. It's a shopping list of all of your software that's in your product. And the flow is constant. If there's a change, someone has to be notified somewhere. And so what is that flow? What does that look like? And I think that's where these frameworks are going to become very helpful. We're also looking at utilizing OSCAL, which is from NIST as well, and it's an automation language. And I think, we've got so many ideas flowing around just now. Say we are working with your product folks at Sneak to see where the best collaboration would be. And I think the first thing is going to be building and showing what we as two companies are doing to create our own SBOMs, how we're storing them and how we're sharing that data. But then I think further on, there's going to be a need and a request, I believe, from the government of continuous monitoring of SBOMs, because the companies and government agencies want to know immediately when something has changed that could make their security posture less strong.
On the one hand, we have a large amount of open source software in our applications across the globe. Now, SBOMs, they could lend themselves to how we may be able to secure open source. But as Guy mentioned, there's a significant component related to the workflow and consumption of these open source libraries and components.
Just to complete the picture, the other stretch of open source supply chain security is around workflows and consumptions. And so that one starts from scrutinizing your dependency ingestion. There have been all sorts of examples of cases in which you think you are consuming library X, but you're actually consuming library Y, or that maybe it's been manipulated in the process. The CodeCove example is a good example in which the compromise was in the file that was being downloaded into customers' build systems. If you were using the hash verification that CodeCove did have, then you would have found out, and in fact, that's how it was eventually detected, that the file you're downloading does not match the hash that was provided on the site. But there are a lot of examples on it for different registries. So dependency ingestion is where it starts. Then you look at what happens after. So the build process, has nobody compromised your build system? And the SolarWinds example is an example of a compromised build system in SolarWinds. So SolarWinds themselves, not their customers, but they themselves were compromised by a compromise of their build system. And then lastly, it's a workflow around response. So you do need to acknowledge that all of these things, you're not going to do them perfectly, and that new vulnerabilities will be disclosed, and that components will be deemed to be malicious. And so you need to build the ability to have some form of real-time response to this. And just like any type of incident that you might practice, you might rehearse to say, okay, if it turns out the component I'm using is malicious or has this log4shell scale vulnerability, am I ready for it? Do I know where this component is? Do I understand the blast radius? Do I know who to wake up and who to talk to engage about this? So that strand is a bit more complicated because it involves people and processes, but it's a different strand around open source oriented software supply chain security.
And that really covers a lot of the main risks that supply chain security can really bring. We've talked about the vulnerabilities in open source projects, as well as whether an open source project can be compromised or not, and also whether a maintainer or a project can be malicious. There's also, I guess, the overall health of a project or a library as to whether that might be close to being abandoned potentially by the maintainer. We've seen projects and responsibilities that have been handed over to other maintainers who later turn out to be malicious, or perhaps overtaking an existing open source project used by hundreds of thousands or more applications, and all of a sudden adding malicious code into that. And that's really where it's dangerous, whereby there are applications that are using components and they don't even know about it. And all of a sudden, one small brick in the wall can become malicious and affect the whole project. And again, the pipeline is a really interesting one, because things like CodeCov or SolarWinds, they're essentially attacks on the actual pipeline compared to an application which is living in production, which if you look back at Log4Shell and that kind of exploit, that was happening against applications rather than the pipeline. So this is more a known vulnerability in open source. But the pipeline example feels more complex. It feels harder than when we think about trying to defend against this. It feels harder than a lot of the application security that we've typically tended to in the past with our usual scanners that we've used for many years. So why is this more complex? What is different that is making this more challenging for us to approach this problem?
I think a variety of components. From a consumer perspective, you just have less control of it. And so you're basically joining midway. You don't really have any influence over how the software you're consuming is produced. And especially when it comes to open source, you're getting it for free and there's no relationship. In fact, vast majority of open source you consume, you don't even consume directly. You're using some open source component that in turn uses others, that in turn uses others. And this sort of indirect place means that you're working with something that's in practice a bit of a black box. Technically, open source is available to you. Technically, open source is open source. So you can sort of see the code. But in practice, because of the sheer volume involved, it's just very hard to understand, let alone influence how well the code is built. And so that's the first problem. The first problem is complexity. And just, there's this huge amount of unknown around what you're consuming. It's just a lot that you're consuming. Even finding out what you're consuming is already a challenge, and you continue from there. The second is who is making the decisions is a decentralized problem. When you buy a piece of software, then oftentimes organizations will have some form of process, and that process will include some form of security assessment of the component and a decision of whether that assessment is proper or not, sufficient or not for you to use. Sometimes even compliance requirements kick in from that vendor. And so at least someone sort of stopped and asked, is this solution I'm about to consume secure enough? And when you're talking about consuming open source, oftentimes those processes do not exist. It is some developer in some team choosing to use something for its functionality. And because there is no purchasing process, because there is no contract with the provider of the open source components, with the maintainer, there's oftentimes also an omission of a security evaluation or a security assessment. And, the software just gets consumed. And this also further happens when it comes to updates and changes. They're just consumed, they're just taken by it. So this is the second piece, which is there is no consumption process. There is oftentimes very little scrutiny around the consumption. That requires a change to a decentralized ecosystem, to a place. Many, many different people need to do those versus maybe a security purchase from vendor. And then I guess the last key problem here is that fixing this and actually leveling up security requires the whole supply chain to eventually change something. And probably the best manifestation of it now is indeed this provision of the SBOM from vendor to vendor. So now suddenly everybody upstream needs to provide you with their description, and that requires everybody to start shuffling. The big sledgehammer purchasing power of the US federal government has really mobilized us into action faster than most. But even then, it's hard to get everybody to change their behaviors. But if you don't get everybody to change their behaviors, then you're just limited. If someone down the line has stated, hey, I guess I'm giving you a flawed sort of software bill of materials, it really affects the validity of anything that comes downstream. And even further, the ability to sort of assess how well they've done their job, how well they've done the security is just very hard. if you think about physical supply chains and how much effort and complexity there is in validating that they are good, it's vast. There are international standards about what good looks like and what is legitimate. There are auditing services and components on it. There are kind of government import inspections. And then at the end of the day, there's sort of somebody to sue if it doesn't work. And open source is, first of all, far earlier in the process, far more decentralized, because there's no physical goods kind of crossing any border. It's far less susceptible to sort of government scrutiny or any centralized scrutiny for that matter. And in some cases, it's even resistant to this type of scrutiny. Open source is a very inclusive and surrounding and tries to be borderless. And so it could be that some consumer says, I don't want maintainers from China, but in open source, it's not always clear if someone is from China or not, and it is not sort of community-wise that acceptable to discriminate against someone that is from one country or the other. And so a lot of conflict that arise. I think the best analogy for the challenge of software supply chain security is fake news. To me, the analogy to physical supply chains is actually almost less apt, or like downplays the complexity of this problem. Just like in social media, where everybody is a broadcaster now, everybody's a content creator, you can just upload your content. In open source, anybody can consume some piece of software. And then it's the community that decides whether they want to propagate that or not. And downstream, you really lose sight of where did this piece of software originate. Just like in news, you kind of lose sight from where did a rumor or a statement or some piece of news originate. And it's crowd dynamics. And so I think we need to acknowledge that it is a very complex problem, and probably a problem that we will never truly entirely solve, not to the degree that we do for physical supply chains. But I do think we're in the very early stages of it. And so there's still a lot better that we can be at. And there are a lot of mitigating controls we can put in place to address it.
This is a truly complex problem, and not necessarily one that has a trivial solution. In fact, it's not even that trivial to what we already have in our estate, what we're using, particularly with the increasing number of dependency graph levels and so forth. With the acceleration of concern that we've seen in the industry, which has led to new standards being created, such as Cyclone DX and SPDX, and even getting new executive orders and attention from governments, it's very interesting to know what actions we can actually take. Who would you say is most notable in the arena today? Who should we listen to, and who should we follow in order to help us with this problem?
I think the industry is rallying to try and tackle this problem. And there are commercial opportunities here, and there are sort of community motions that come into play. Probably the most notable is the Open Source Security Foundation, or OpenSSF for short. OpenSSF is a child foundation of the Linux Foundation. And as you may or may not know, the Linux Foundation and the OpenSSF, they're not really like a standard foundation.
So started in early 2020 when a set of companies who've been leaders in the open source space started to realize, well, maybe there's some things systematically that we could do with the tooling and infrastructure that the open source communities use to improve the default level of security that people should come to be able to expect from open source. So basically, it was launched with this idea of how do we systematically improve things? And a whole lot of volunteers showed up, volunteers from all sorts of different companies, lots of vibrant conversation about, well, it's an education problem. People don't know how to write defensive code. Well, let's create some training materials and guides for what to do when somebody shows up at your open source project and says, you've got a vulnerability. What should you do? Right? Others who looked at, what are the most critical packages? And that famous XKCD comic of that one little box in the lower right that was holding up everything else, and it's two people in their spare time maintaining it. Well, how do we look for those kinds of packages and try to identify them before they become a surprise? All right. So there's a whole group focused on identifying critical projects, but really trying to understand if we're going to focus some resources and attention, what are the ones that work, that really deserve the most attention. And I think my biggest hope is we can work with many of the companies out there building security tools, as well as with a need for highly secure environments, and get folks to combine efforts on different things rather than, coming up with 20 solutions to the same problem.
Yeah. I'm recently elected to the Technical Advisory Council for the OpenSSF, the Open Source Software Foundation. I'm also elected to the board of directors for the OSI, the Open Source Initiative. That's the sort of long-standing neutral body that reviews licenses and gives them a sort of a stamp of approval to say what is an open source software license and what isn't. Most open source bodies or foundations that produce software, some don't, some are more advisory, some work on policy, but the ones where a lot of us are familiar with also produce code. The OpenSSF is sort of both. It produces lots of guidance and written documentation. So it has working groups that do those things. It also has some software projects and it's beginning to collect a couple projects that run a service. And so based on the charter of the foundation, the governing board handles the big decisions around funding and sort of governance of the whole thing and delegates technical authority to the TAC. And then the TAC has this role of not micromanaging projects, not paying attention to every little detail. There are only 7 of us. We can't do that. But setting the policies and having check-ins to ensure that all of the working groups and the projects in the OpenSSF are healthy, they're well-functioning, everything's transparent, people know how to find each other, and it's a healthy community producing good software and good recommendations.
The Security Technical Advisory Group within the CNCF is the group that is designed to support the Technical Oversight Committee in reviewing and kind of driving the direction of security for cloud native projects. It's a little bit different than the existing technical advisory groups within the foundation who focus on key technical domain areas such as networking and storage and really get involved in those projects of those domains to allow them to reach a higher level of maturity and adoption and integration with the rest of the community. I will say, because open source as an ecosystem itself is so massive and it has such a rich heritage of different processes around how we do software development, I'd say about 50%. And I say that as we are transitioning into more microservice and containerization within the landscape. So while cloud native is in itself its own unique ecosystem for the architectural design decisions that are in place with it, promoting distribution and immutability and ephemerality of our workloads, there is still a lot of core security primitives that apply within normal open source projects, and that universally anybody can go to our documentation, our recommendations, and be able to apply them at some level to whatever their situation is.
The OpenSSF, as Guy Po mentioned, is really one of the main community initiatives that is tackling the challenges with open source and its implications on supply chain security. You heard from Brian Behlendorf and Jim Zemlin in part 1 of this series. Let's hear a bit more from Jim about how the OpenSSF came to be and where things are at today.
And then in December, Log4j happened. And this was this incredibly high profile open source compromise. And then in January, we're all sitting in the United States White House talking about open source security and the software supply chain. And we sort of are looking at each other saying, well, at least we were a few months ahead of needing to convene to really find a more comprehensive way to deal with this. So that's really how the Open Source Security Foundation started. And I would say we're at the pretty early stage of what's truly needed to work on our collective software security, which is bluntly millions of dollars to go and let's go train 1 million developers in how to write secure software. If we provide free training, let's say $50 a developer to stream that kind of a course over some learning system, that's $50 million. If you're training 1 million developers for 5 years, it's not zero. We need to go and work with the major package managers to provide them resources, knowledge, and engineering support to improve their security baseline, build better systems for cryptographic signing and other components that would make those package managers more secure. We need to go and continue to understand what the most critical open source projects are out there and audit them. An average audit of a mid-sized software project costs somewhere between 50 grand and maybe $80,000. And when I say audit in this case, I'm not talking like a static analysis tool or anything. I'm talking like eyes on code, reading it, going through and really taking a deep dive into that security. That's something that needs to be resourced and should be focused on, let's say, the top 200 most important open source projects that are out there, and then work with those open source maintainers and developers to take things you find in that audit and fix them. We need to build and provide additional tooling. This is where Snyk has been just this amazing partner to the Open Source Security Foundation to allow open source projects that are critical to all of us to scan that code, understand out-of-date dependencies, vulnerabilities within their code base, do static analysis on that software in order to find and remediate bugs, provide a set of development resources to not just find the bugs, but have folks who could go in and fix those bugs. and then continue research on our never-ending search for what are the top, most critical open source components out there that we need to really focus on. All of that combined is a multi-$100 million collective effort. But if successful, that has a massive force multiplying effect in terms of raising our collective security and would greatly reduce the risk of another Log4j, which costs a lot more than a few $100 million to remediate. The damage of these compromises is in the billions. It's just, we've got to get ahead of this. And that's what the Open Source Security Foundation's role is, to coordinate with industry and government.
While the OpenSSF and its members are playing a pivotal role in this battle, the second critical player is the US government, as Guy Po and Jim explain. Lena Smart from MongoDB also shared some information about this topic.
A second notable player is the US government. The US government is actually doing a lot of work over here. The executive order we've mentioned a few times is an example of something they've done using the purchasing power of the US federal government to drive change. It wasn't a bill, it didn't go through Congress. It was a statement that said, sort of simply put, here's a bunch of security requirements that we have of you, including this demand for the SBOM. We demand that you provide us with an SBOM if you sell into the federal government, and that you cascade that down your chain. And we're not really going to audit you. They didn't require all of that auditing. But if you don't do this right, and we find out, you're never going to be able to sell to the federal government again. And so it's such a big scare, such a big fear, that it really mobilized everybody into action. But there are more specific guidance points that they provide in the executive order and in subsequent mentions. Also, there was some more guidance coming after the Russia-Ukraine war broke out of fear for sort of more activity from Russian hackers. And more recently, there's actually now bills starting to try and kind of pass through Congress, like the Securing Open Software Act, that try to really codify into law, into practices, requirements around security as a good industry practice, almost like as anti-fraud style protection that say, well, you have to protect your consumers, and therefore you have to do these things. On one hand, they talk about that. And on the other hand, they acknowledge open source as critical infrastructure for the government, for the world, and therefore they justify governmental spend in helping secure it. And so the US government is actually a pretty big factor. Clearly, government, with all the sort of pros and cons, of their involvement, and maybe the technical accuracy is not always quite as high, but they're another player to watch.
One of the things that government can help with is just using their influence and convening function to get industry to collectively come to a consensus about tackling this problem. And so that's really what we did in the White House meeting in January, sort of agreed upon about a half a dozen things that we think would really improve the baseline for security. Let's go audit those critical projects. Let's provide critical open source projects tooling. Let's train developers on how to write secure code. Let's shore up those package managers. Let's build tooling to allow software bill of materials metadata to more smoothly flow across the supply chain so that end users can have a better manifest of the software components that they're using in order to remediate vulnerabilities that will inevitably happen over time. That alone is a super useful role for government. The difficult part of that is, even if you have a great specification, even if you have a will, in the case of government, to require this, there is a lot of stuff that you need to create to make that supplying these software bill of materials manifests. I think some people would say easy, some others would say even possible, right? But there's a ton of things you need to build. How do I create tools that allow a developer to easily create software bill of materials descriptor for their particular component? How do I make sure that package managers can have an ingress and egress of software bill of materials metadata as they're distributing software components? How can I make sure that the place where software kind of all comes together in the build systems, do I allow for the ingress and egress of software bill of material metadata? This is actually a problem, but what's great about this need for building tools to automate all of those different ingresses and egresses of software bill of material data, I think it's a relatively definable, doable software development effort to build all that stuff. So I think that what we'll end up seeing as government starts demanding software bill of materials as a requirement for the software that they consume, or if they pass regulation or federal agencies require software bill of materials data, what you'll see is a demand for software that automates that flow of software bill of materials data across the supply chain. And this is something where we literally have a team right now working on, think of it almost like a PRD for the tools that will automate this stuff. And we got to get out there and build it. I think it can be done fairly short order.
The ITS ISAC, and they describe themselves as a force multiplier. And they are this amazing group of people. It's been around for about 21 years now. And they actually enable collaboration between public and private industry. And so I had a lot of, and there's ISACs. So there's 16 critical infrastructure groups defined by the federal government. And the IT ISAC is the Information Sharing and Analysis Center. That's what the ISAC stands for IT. And so I used to be a member of the EISAC, which was the electric sector. And again, it's to do with information sharing. It just brings people together who maybe normally wouldn't sit at the same table. It's recognized by DHS. So we get some of the most amazing speakers. I mean, we've had Jen Easterly come speak to us, head of CISA. You know that Jen Easterly, she set up so many things, but she set up the Security Commission basically to not oversee, but I think just be part of some of the policy and fundamental decision-making processes when it comes to cybersecurity for the USA. There's some members of the IT ISAC who have joined that commission. And I think it's just really important that private industry and public industry can work together in a trusted environment. Obviously, before the pandemic, we were meeting in person, and I've just made so many contacts of using the IT ISAC. It's an amazing resource. They have little working groups that I'm a member of the Supply Chain Risk Management Working Group, no surprise there. And then we're also working on some other stuff as well, some special interest groups they're called, or SIGs.
And then the third key one that I would say is just the commercial cohort of vendors that are in the space. There are some existing players that were already helping you wrangle your use of open source. Snyk is one of them. There are other sort of software composition analysis players that help you understand your kind of SBOM and address those. So these players are generally providing new capabilities related to indeed that reporting of the SBOM or maybe the trustworthiness of components. And so that's sort of one cohort of players to watch, that this is a bit of a boost in terms of the business because more companies need to adopt this security practice. To be frank, a somewhat secondary set of new capabilities that need to be done, because these players to begin with were sort of mandated to help you know which components you're using and where they are. And so the technicality of being able to export that into a file in some standard format is very much the sort of the minor feature. There's another cohort of newer commercial players to try to tackle this pipeline security journey of an open source component or sort of a piece of software, and tackle these problems about secure consumption, around anti-tampering within your build process, or even to an extent, response to malicious incidents that are kind of coming up as supply chain security vendors. But really, they're mostly focusing on tackling that. And maybe there's slipping a bit into the SCA world as well. So I'd say those are the primary cohorts. There's a fourth small stream that is basically SCA and supply chain security related features that are coming up across the ecosystem, because as we think about this as supply chain, any piece of software that tries to manage, for instance, like your asset management in your system, maybe now add a capability to know what is the SBOM inside of it. You know, a lot of any IT workflow and thing that interacts, that helps you interact with your vendors, might want to do that. Any security assessment tool or even protection tool might want to be aware of your components. And so there's a wave of supply chain security features that get added to existing players.
There's a lot of things that we as organizations can do better ourselves in reducing the risk in our overall supply chain and our open source, in our pipelines and so forth. But a lot of people will probably feel quite overwhelmed with all this and think, there's a lot here. There's a lot of pretty big lifts that we need to take here. I don't know where to start. I don't know what to pull in. or who to pull in to help me out with this. So in terms of some of the initiatives that that's out there or projects that we can use to help us, who would I as an organization want to look to or look to help me with some assistance in some of these solutions?
I think the top projects to look at from an ecosystem perspective, to monitor, to collaborate, to join, are primarily in the OpenSSF world. Top ones to be mindful of and maybe start considering adoption of the SALSA framework, which was donated by Google, the SLSA framework, which just provides some structure and some conformity into how to think about the problem and how to break it up. Some debate a little bit about whether it is attuned for larger organizations. So small organizations, it may or may not drive them, but it's good questions to raise. The second key one is really the world of the SBOM formats. So you just want to be on top of that. There are two primary standard formats up there, the SPDX and CycloneDX, both good formats with some deltas on it. Probably both have a good shelf life. So being aware of those formats, and the world of SIGSTOR and its related projects that help you practically apply attestations and know whether something actually has occurred and verify that downstream. And so there's a whole world of ecosystems. So looking at SIGSTOR is very, very important. Another key project to track is Scorecard as you try to evolve your evaluation of whether a component is trustworthy or not. Scorecard is very an initial but good start to how do we score an open source project to it. And there's a lot of effort in the LFX, the Linux Foundation's platform, that curates a lot of open source projects, focusing on Linux Foundation projects, but I think over time growing to more, and tries to give you all sorts of information about those open source components. It includes some vulnerability information, includes funding information, includes maybe some information of the maintainers to the extent that it is legit to do so. And it will start including things like the scorecard. So understanding the scorecard, seeing if those parameters apply to you, seeing if you want to contribute to them is all very helpful to it. And I'd encourage using LFX as a means of asking that question about projects you might be consuming.
LFX is a suite of tools primarily intended for Linux Foundation projects to help them do stuff. And now there's a whole bunch. You mentioned LF Security. LF Security is intended to be a suite of tools to improve security. The one in there right now is basically looking for dependencies that have known vulnerabilities. It's using SNCS technology, and we do intend to add others to that tool chain. And actually, just in general, the goal is as people say, hey, I need this, and we start noticing, oh, wait, all our LF projects need that, then sometimes they work with organizations outside, and sometimes it makes sense to try to provide them with tools. But coming back to the whole security thing, it's important to have tools in the toolbox. And that's one of them, is looking for dependencies which have known vulnerabilities.
But fundamentally, the most important thing you can do to improve your own open source security or supply chain security posture is to start by just making sure that you know which components you're using, what are the problems in them, and how do you address them. And in conveying to the upstream maintainers that this is important to you, to convey to the world that you have chosen library X over library Y because you believe it to be more secure. And open source maintainers are amazing individuals that are producing free software that makes the world better or more productive, and they're really great. And fundamentally, they cater to their communities, especially the top ones. So the more their communities express a desire and importance for security over functionality, the more weight they get from their consumers to say, I am willing to forego this enhancement, this performance boost in favor of you prioritizing doing this security practice, the more they will lean that way. And in some cases, if you yourself have the security expertise, the security cycles, this is also a great place to contribute back to those projects, to go to those projects, find missing security controls. Maybe it's a security assessment, maybe it's security review, maybe it's just integrating some tool into a pipeline, or fixing a security bug, and apply your resources, your cycles in your contributions, because oftentimes enterprises and corporations as a whole have more security competency inside than necessarily those open source maintainers. And so I'd say more than anything, from a broad call out perspective, it's less about having more people join in these OpenSSF projects. They have a lot of attention. They could use support, but they don't need 1,000 more people joining them. Mostly it's around driving sort of the importance of security across open source projects wherever they are.
So Guy Post really beautifully wrapped that up there. And I actually totally agree. This is such an important area for us to be able to give that education and feedback right into the maintainer spaces. And when we consider our own organization and internally within our own organizations, there's probably a lot of folks who equally concerned about the supply chain risk, equally concerned about their organization becoming the next org which suffers a breach due to the supply chain exploit or an exposure. And it's not just down to those folks as to whether they're in a security team or whether they lead the dev org. You need that buy-in, and you equally need that similar high priority or similar concern among your development organization. And I mean grassroots developers, who are the thousands of developers that people will have in the organization. So I guess there's two pieces here. First of all, what advice would you give for any security individual, security team that is trying to raise that awareness in a development org? Many developers as possible, we want recognizing this is a potentially high risk concern. And secondly, what are the best strategies here to actually give actionable, good security hygiene practices for developers to use? We're going to tackle these questions and delve into recommendations and suggestions from experts that we've spoken to in part 3 of the Supply Chain Security series on the Secure Developer.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at DevSecOn. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.